Okay, welcome to week 9. Last week we have started about design patterns. So let's wrap it up. This, I would say, quite important topic. Okay. Last week we have learned 2 structural design patterns called facade and adapter. So the 2 of them sort of serve some sort of as a bridge to help us to either to uh, adapt to some new backend or to simplify some old backend. So we use that to simplify how programs interface and improve uh, uh, the loosely coupling methods to make it more loosely coupled. So today we will finish, but first we will discuss in general what kinds of reuse there are, and also we will go through the 3 main categories of design patterns, and we'll learn more design patterns. But more importantly, uh, we'll see some good examples of how to use interface. I think some of you, as a Java programmer, sometimes you would wonder, when should I use the Java interface? So today you see some very good examples of how to use them effectively. Shh. Thank you. First, introduce you a guy, Christopher Alexander, and he's an architect and a professor of emeritus. And we know UC Berkeley is, first of all, University of, in case you don't know, in the United States, most of the top universities are private universities. For example, MIT, Harvard, they're all, most of them are private. In fact, the best ones tend to be private. But there's one exception, UC Berkeley. UC Berkeley, U of California is a public U. But I guess the problem is because the government subsidies not so much, so they charge very expensive fee, almost approach the private U. Okay, so if you have a chance, then by all means, I think it's a very good atmosphere. And in fact, a few decades ago, Berkeley, the people in for one thing, Hollywood is in California, and so the people there tend to be more freestyle, especially the people in Berkeley. They were very active in social movement, at least once upon a time they were. So the title, Professor Emeritus, I tried to look up the Chinese meaning. It says 榮譽教授, but also there's another name called Honorary Professor, also translate to 榮譽教授. So what are the differences? Well, with Honorary Professor, you usually, let's say, if I'm very famous, of course it's not true, but if I'm very famous, so some other university find out about me, they may give me an honorary professor at their university. So you give a title to someone from another university. But for Professor Emeritus, it's usually when you retire from your university and you have done great achievement, your employer, your university want to show their appreciation, they grant you a Professor Emeritus when you retire. So that is a very great honor, because honorary professor is more 第二間學校俾面, okay, then they give you one, okay. But Professor Emeritus is your own university recognize your status, and usually out of 10 people, there's less than one will become Professor Emeritus. At OpenU, in the past, I've only seen Fu Haozheng, after they retire, they become Professor Emeritus. I've never seen anyone other than that. Okay, but he's an architect, so what does he have to do with us software people? Well, first, he wrote a book called A Pattern Language, Towns, Buildings, Construction. Okay, so he asked in his book the meaning of quality, and also is quality always subjective? That is, you think it's good, I think it's not good. Or it is objective. Everyone more or less agree. So he asked this question, and he tried to, for example, when designing a door entrance to some place, is there a common characteristic of good design? So he asked this question, okay? And his book inspired two guys, Kent Beck and Ward Cunningham, okay? But let's go back to the pattern thing. So from building architecture, he focused on objectiveness and also repetition, because if you can repeat, for one thing, repetition is very important in engineering and science. If you cannot repeat something, then it's not very good. And when we're making a product, we want to be able to repeat people's success or previous success. So we look for commonalities. So is there something similar? But commonalities is specific to the kind of problem. For example, in the case of architecture, building a music hall, a concert hall, commonalities of good concert hall will be different from commonalities for a good residential building or a good commercial building. So commonalities would be very specific to the type of problem you're trying to solve. And also, let's say if you're building a structure near the waterside or in the mountain, your consideration will be different. So it's also depending on the problem, and it's also depending on the situation. So this is some basic thing that Alexander has looked at. So he tried to document some patterns by giving it a name, describing its purpose, describing what problems it's trying to solve, and how to solve it, and what kind of factors, what kind of attributes that we need to consider. So he solved his architecture problems for buildings. And two very creative guys, Kent Beck and Ward Cunningham. We know Kent Beck is a very accomplished guy in agile methods. The extreme programming, test-driven development has changed the world of software development. Okay, of course, the effect is not when you have a new invention, and if this invention affects how the way people work, the effect won't be immediately observable. It takes maybe 10 years for the whole world to realize the potential benefit. Okay, so the first 2-3 years is not, many people would not even know what TDD is. But of course, now the world has changed. Even, I think a few years ago, when I went to go for some agile method workshop, I've met other people, and also I know people from Cathay Pacific, South China Morning Post, those relatively large company. Originally they tend to be conservative, but even now they are moving agile. So you can see these people are very influential because of their creativity. And where do they get their creativity come from? Okay, lots of time how to be creative is you merge ideas together. You borrow ideas from another field. For example, they borrowed the idea from Christopher Alexander. So they try to look at uh, previous programs, and they identify 5 design patterns for some problems that are encountered again over and over again by programmers. So they describe them and they publish a paper in this conference. But too bad I didn't meet them because, of course, 1987. I think none of you were born yet. I think I went to this conference 1988 or 89. Okay, so it was a year too late, so I could not meet these two guys. But they so it was very influential. So people think, oh, it's a good idea. So why don't we learn uh, from previous solutions? But we are learning their design. Okay, so and this their paper affect 4 guys. Okay, is some of these names I don't even know how to pronounce it. Okay, so they work together 4.5 years, and they look at, I guess, lots of programs and so on. They do some somewhat like the literature review some of you guys do in your final year project. Even you're not doing it this year, you'll do it next year. So they've done good research, and they find out, they discovered there are 23 design patterns. Okay, they wrote a book, and I think our library should have it, or public library should have it. This book was authoritative, but I don't. Computer scientists, researchers, they always like to write paper that are very hard to understand. So even their books sometimes are hard to read. So I guess unless you become very good, have some basic knowledge, this may be a difficult book to read. Okay, but let's clarify what is not design pattern. Design pattern is not a new algorithm that a smart person invents. Okay, it is not. Actually, it's the other way around. It is an algorithm that people used again and again. Okay, so people start to realize that, oh, we have this design is used over and over again, and it is effective. So let's document it so that other people can learn about this pattern more easily by some well-written documentation rather than from hundreds or thousands lines of code to learn a pattern. So this is what a design pattern is. And design patterns, probably most companies would be used for mid-level design, but occasionally you can use it for high level or low level too. I guess when I first learned design patterns, I also thought that maybe it's all theoretical discussion. Maybe it's not as useful as they are, but actually when you start to see, the more I get into it, for example, from JPA, I learned that they have something called factory method pattern, which is one of the patterns we will learn today. And you will see several, especially the creational patterns, are actually quite commonly used in the class library. But of course, if you don't know the name, you may still be able to use the API. It may be okay, but if you want to, let's say, modify someone's code, and if you don't understand the pattern, then you'll have a difficult time. So as a caller, calling these API will still be good. But of course, JPI, you may not have heard of it. It is something, you know that when you write Java program, OO, okay? The concept of OO is like a collection of objects. It is quite different from relational database. So whenever you need to use a database, what can you do? Okay, if you construct your select statements or query update statements, it's actually quite cumbersome. So if you become a serious Java programmer, you probably need to learn something like JPA or something called Hibernate. Hibernate is a slightly one of the older thing, that a library that helped you map OO to relational database very easily. Okay, so when you write program, you have an easier time. You don't need to deal with SQL statements. Even if as long as you have the use of a JPA, then you can access the relational database without writing any SQL statements. Okay, and finally, design patterns may not solve all our real-world problems, because some problems may be new. So you may still need to invent your own solution from time to time. And also, maybe you can combine several design patterns to solve a new problem. Okay, so let's look at how we've seen in a few slides ago how Alexander described architecture, building architecture, okay? And we have a few more views. We give it a name for design pattern. What's the purpose? What problem we're solving, and what solution? Sometimes we use words to describe a solution. Sometimes we use a diagram to describe the solution. And participants, what are the major components in the design? And maybe they can show you some code. I would also try to show you some code to give you a feel what it's like, and some benefits and limitation analysis. Okay, so we don't have one design pattern for all problems. So for each specific problem, we may have a good design pattern to match. Of course, there may be some limitation. For one thing, we reuse design, and if someone uses a design pattern to create a piece of software, they can use a few hundred words to describe the design, but probably they can just say, give you the name of the design pattern. I'm using this pattern, and this class corresponds to this component, and that other class corresponds to that other component. So just several lines, as long as both parties know the same design patterns, just a few lines, they can communicate very well. But otherwise, it will take much more words to explain to people what you are trying to do. Okay, so we always emphasize programs should be easy to read, because if we don't understand the program, we cannot modify it correctly. So giving it a appropriate design pattern name, and it helps us understand, and it helps us to design. And as I mentioned earlier, we will be showing you how to use Java interface to solve some of our problems. And that same use of interface may help you solve other problems too. There are three levels or three kinds of reuse. Class libraries is the simplest in a way, because you just make some API call, or you inherit a class and create objects. So that's quite easy to do. And frameworks is another kinds of for example, we have a very old one, fewer and fewer people are using it now. It's called struts, and also another very popular Java framework is called Frame, and you have other framework for PHP and also different languages. So what are frameworks? Do I have another slide? No. But in a way, I would just do it very quickly. Framework can save you some code, okay? So they will generate some code for you. That's what framework does. And but you have to learn how to use a framework. Uh, so I strongly encourage you to, there's a course to be taught by Keith in 4th year. It will teach you Spring. And if you want to work as a Java programmer, that course should be useful, the Spring, because of the Spring framework. Students, so it's not enough just to know Java. It's not enough just to know PHP. You want to know a popular framework in that language. Design is different from the two other kinds of reuse, because design patterns, you're just reusing the design. You still write all your code. You're not using other people's code. That's what design patterns. So in different times, you use different kinds of reuse, depending on what you need. Okay, and class library, some pre-written code. Okay, for example, Java standard library. Framework, developers framework, they often use MVC architecture. You will provide some configuration files, some XML files. So it's interesting because if you're using a framework, there's a good chance you would be writing not just Java program, but actually configuration files. Sometimes configuration files are written in XML. Of course, you follow some syntax of that framework to write the configuration file. So that's how they create the linkage of different components. That's how they create the code to link different parts together. So design patterns will also learn abstract factory today. I guess I've discussed most of this stuff, but I would introduce this term called inversion of control or dependency injection. The two names are sometimes used interchangeably. Their difference is very small. Okay, if you are writing all the code by yourself, you can find out in your own code. Let's say A is calling B, B is calling C, and so on. So all those A calls B, B calls C will be in your Java language. But if you are using a framework, actually it may be different. You will provide A, the Java program, and you will provide the B, Java program. And where's the linkage? The linkage could be in an XML file. They will try to link A and B together in an XML file. But of course, I'm just giving you the, so you're saying, well, if it's just XML file, then who decides when to call it? Well, that's the kind of code that the framework will generate for you. Okay, it will decide how to make the linkage for you. So it reduces the amount of code you need to write, but you have to learn something new, okay, about how to specify the relationship using this inversion of control. It's no longer A calling B, B calling C. It's A and B separately, and you have a configuration file that link A and B together. Okay. So just two more slides before our first break. We have Uh, last uh, last week we have seen the structural patterns. Structural patterns is about how objects relate to each other, who associate with who, and uh, who knows about who, like who has the pointer pointing to that object, who can call the other person. So we've seen adapter. Uh, if you are changing to a new back end and that new back end does not work with your existing code, you use adapter. Bridge, actually, I purposely uh, do not teach bridge because it would be like somewhat similar but quite different. So to make life easier for you, I skip bridge. Okay, there are also composite, decorator. Decorator, um, I won't get into them like in this course. Okay, proxy is someone uh, to control, like as to help reduce complexity. So we've learned the colored ones last week, and there's another kind called creational patterns, singleton, prototype, factory, builder, and abstract factory. And also we would study the colored ones today. Um, Students sometimes complain about too many things to remember in my course. Of course, I will not ask you in a test or in an exam to say, give me the definition of builder. Okay, this is too boring. Okay, in fact, even I teach abstract factory, I will not ask you to write out like this other part. I would give you enough information to remind you a little bit of abstract factory, and then perhaps ask you to finish the discussion. So as long as you understand them, uh, you have read it maybe more than once, maybe twice, then you should be able to, as long as you understand it both times you read them, you would have no problem. I think we have a test coming up before Christmas holiday, okay? Because I want you to enjoy Christmas. Don't have to worry about a test after coming back from Christmas. So I'll give you that. And we've seen structural patterns here, creational patterns here, and the third category is behavioral patterns. Uh, Again, it's a little bit too much here. I would just show you two behavioral patterns today: observer and strategy. Okay, and so let's take a 5 minutes break for now.